Welcome back, guys. So we're going to get in real quick to part 2 with David Rames on multi-zone ductless. Let's go. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. Cool. So on to the next one for outdoor installation. We talked about each zone getting its own set of piping, own set of wiring. We also have to individually pressure test each individual. We can't pressure test the whole system. It's got to be that line set to that head is pressure tested and then go down on that path of each one. And then the same with evacuation. We need to evacuate each line set separately as well, right?
Yeah. And so you better, and let's just face it, you're going to have a line set go into each indoor unit. And let's say you have 6. And if you don't pressure test that, we can blame it on folks, the younger generation, not being able to make a good flare, or you can blame it on maybe the quality of the line set isn't quite as good as it used to be. But for some reason, some flares aren't holding up. And so what a better time to see whether that flare is good and tight and sealed than when you're at the job site before you fill that thing full of refrigerant. So you're right. Pressure test everything. Make sure you got a good vacuum, make sure everything's sealed up tight before you leave. And next thing you know, the refrigerant, which as we know is not getting any cheaper, for the refrigerant leaks out and you got to come back because you got a no heat or no cool call. And it was basically based off of a cracked flare and we lost all the refrigerant.
Yeah. And I was on a job site last week, I believe it was, with a younger tech installing central heat pump, and it was a flare connection to the outdoor unit. And I showed him a flare gauge and he'd never seen one before. And I said, do you know what this is? He's like, no. I said, well, if you have all flares now should be at a 45-degree angle. So the flare gauge, if you put your flare through the gauge, there's a little stopper in there. You can barely tell it's the stopper's there because it just sticks out ever so slightly in the hole. If you put your flare into it and it stops, then your flare is at the right angle. But if it goes through, it's not. So whatever tool you're using, maybe it has malfunctioned. Maybe it's not even a 45-degree angle flare tool. That there is super important. You have to make sure it's at a 45. And if you go to a leaking flare and you pull it off and it looks good and you have a flare gauge, put it in that flare gauge. And if it goes right through, that could be one of your problems right there.
If it doesn't seat, it's going to leak.
Yep.
And so we got to get it seated up tight. And the other thing, which everyone knows is, and I'm going to assume there's probably not a tech at one point in time during his life hasn't did that, put your refrigerant nut on a line set first before you flare it, or get your tubing cutters because you're going to do it again, buddy.
Yeah. Oh yeah, the most perfect flare you'll ever have is always the one where you forgot to put the flare nut on, right?
And if someone says they've never done that, they're probably lying.
Oh, of course they are. I've done it. I've done it many times. The other thing too is that and I've made this mistake. So let me go back to about 3 years ago. It was a 1/4 inch to VRF heads, and when I pressurized the system, a few of them were leaking. The 1/4 inch ones. I preach using a torque wrench on that job. For some reason, I didn't. I don't know if I couldn't find it or if it was just, I had no excuses. I'm not making excuses for myself, but I didn't. So I'm going to come clean on that. So when I went back to these 1/4 inch flare nuts and took them apart, like the copper was just flattened. There was no flare left because I had over tightened it. And then I went and redid them. I redid the flare, and this time I used a torque wrench. Now, I don't know how you feel about Nylog, and you don't have to tell me your opinion, yes or no, but I use Nylog on all my flares. I've done it for 2 decades pretty much. So I reapplied that. I use a torque wrench this time, and it stopped. Like 1/4 inch, it's really hard to gauge if you don't have a torque wrench because you can just go ever so slightly, like that doesn't feel tight enough, and you just keep going. The torque wrench, it just beep, 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 it stopped. And I'm like, whoa, that doesn't feel like it's tight at all. But hey,
it doesn't matter what you think.
It held 600 PSI. It held no problem. And it's a 3-year-old install, and there hasn't been a callback on a refrigerant leak. So the torque wrench did me right, and my handle meter did me wrong. So
I would assume that if you don't use a torque wrench, you're going to be more apt to over tighten than under tighten. And there are issues to both, right? But if you over tighten, next thing you know, you got a split, you got a leak, you leave, everybody's happy, and then the phone rings a few hours later and you're coming back.
yeah, and the young tech I was working with last week on the job site, he didn't own a torque wrench, and I said, "Here, I'm going to let you use mine, and we're going to look up the torque specs, and we're gonna put it into the torque wrench." And he tightened it, and it beeped, and he goes, "Whoa!" He goes, "I if that was like me, I would have went like another like quarter inch, right, just to make sure." But same thing, he leak checked his line set after, and it was completely fine.
And it's all in the installation manual. So we just did some training here for a new customer here in Louisville over the last 3 days. They're not knee pads, they're installation manuals. So read them. Now, after you read them and you understand it, I don't care if you use it as a knee pad, but read everything you need to know is in there.
Now, you might be able to answer this. In most of the manuals I've seen, anyway, there's a range of torque. So let's say it's 3/8 or quarter 5/8 or whatever the pipe size may be. There's a range of torque. Why is there a range and not one set torque? Is it because maybe some tools might act a little different than others? Like I don't know what the reasoning is there for that.
Yeah, I would assume that not all torque wrenches, like anything, are created equal.
Yeah.
And so I think anytime you try to dial something in exact, you may create more problems. And I would say if we went out and bought 10 different torque wrenches and did a test, they may be off a little bit. And so you give you a little bit of leadway there. As long as we're not way too loose or way too tight and you're within that spec and you made a good flare, you should be good to go.
So what I do is I always, if there is a range, I've seen manuals where there's no range. I've seen most manuals that I've looked at have a range. What I normally do is I hit mid-range and then leak check. That's what I tend to do. Just, I don't know, I just feel mid-range is probably a safe bet to be a starting point. And then if I pressure test and there is a slight bubble coming out, then I will reset the torque wrench to the higher level within the range and just give it one more little bit of a turn, and that usually solves the problem if the mid-range doesn't work.
You got to snug it up. Just what we don't want you to do is put some channel locks on there and stand on the end of them, or a crescent wrench and stand on the end of it and go, I'm going to stop this leak. Watch this. Put a cheater bar on there, so it's a delicate situation. If done right, works like a champ. You never have to worry about it. But let's just follow what the manufacturer's installation instructions say. Pressure test, leak check, and then everybody should be happy from there.
Now, what do they recommend for leak testing when we're trying to, like, when the install is done? Is there a certain limit they want or a certain range before they say, yeah, like, is it 400, 500? Because we all know with 410A units in heating mode, the pressures can get like they can get up there, right?
Right. Not really. I mean, I would say that my tech team would probably have a different answer to that. But I think, as long as you do a reasonable due diligence on pressure test and it can hold it, we should be good to go. But as we know is, the other part of this is we don't use a liquid line filter dryer. So we got to try to keep all the schmuck out of there before it gets into the strainer, into the EXV and screws some things up. So just do your due diligence, take your time, do what the manual says, and 99.9% of the time, you're going to come out the other side safe and sound.
Is there a reason why there's no liquid line filter dryer in the outdoor unit, in the actual liquid line? Is there a reason for that?
There is a restriction. Anytime refrigerant flows through something, there's a restriction. And then as we flare everything, so all through the Midea products, every product that we have, other than our cased evaporator coil, everything's a flare. And so with that, we just feel like if you keep it clean and you flare it correctly and you get a good seal, there's no real reason for it. We'll just let that refrigerant flow.
Evacuation is super important. We want to get below 500 microns, 300 if possible. There's no reason why you can't on a brand new system like that. Now, a lot of techs are still unfamiliar with a decay test. Decay is when you get to that point that 200-300 microns, you valve off from the pump and watch a rise in your micron gauge. If there's no rise in a few minutes, you're probably doing really, really well. If there is a rise, you pop up to 2,000-3,000 microns, you probably got some more work to do. If you have a rise that continues to go up, but you've leak checked the system at 400 PSI, let's say prior, and it held for an hour, you probably don't have a leak in the system. What you probably have is a leak in your evacuation setup. It could be in your hose. It could be the micron gauge attachment. It could be anything like that. And I've seen it in the past where my evacuation I'm at like 1,200 microns and it's like just slowly coming down. And then I tighten up like a connection point on a hose or something like that because it came loose or I didn't tighten it enough, and then it just starts plummeting. So always be cautious of your evacuation setup. Make sure none of that's leaking because that could throw you off and think that you have a leak in the actual system. The other thing that I want to say too is that some guy on TikTok told me 5,000 microns was the limit because an old tech or an old mentor told him 500 will implode the piping. That was what he said. Like literally, he said, no. He's like, no, I learned this from an old guy. If you go down to 500, it'll implode the piping. 5,000 is where you should be. So give me your take on evacuation decay tests and how it's super important for that machine.
Extremely important. And let's not forget that nitrogen is one of your best friends as well, right? So we want to keep the sealed system sealed. And before we seal that system, we want to make sure it's free of moisture and free of debris and all of that. And so when you've got a system like this, and it's an intricate system, we want to make sure that everything's out because you've got electronic expansion valves that are sometimes pretty sensitive, and anytime there's outside contaminants in there, they never do good things. I know that. And so let's get it pressure test. Let's make sure you don't have leaks. To your point, exactly, it may not be the system, it may be your equipment. So take your time, make sure you have enough time for this new installation where you can take your time and go through all your ABCs at 1, 2, 3s and make sure everything's the way it's supposed to be. Because let's face it, the equipment's expensive. The labor to install is expensive. And that homeowner is about to write you a sizable check. Let's make sure they're happy and comfortable when it's done. And then, as we know, then referrals start rolling in, which are definitely good for the business.
You hear it all the time, David. That unit's a piece of shit. I mean, but maybe your install is. Maybe you don't install properly. Maybe your flares aren't good. Maybe your evacuations aren't correct. Maybe you run your evacuation on time and think that's suitable, but you don't actually know what you're pulling down because you don't have a micron gauge attached. And this is what bugs me about a lot of people in our industry. When you get on, and some of the comments that come through on these YouTube, like the YouTube videos of the podcast, we just had one a couple weeks back, not even maybe last week. We're talking about leak checking with an electronic is the way to go. And some of the comments were like, no, nitrogen and soap never fails. Like just take the refrigerant out and, you know what I mean? And put nitrogen in and go to town. I'm like, no, guys, like take your electronic with refrigerant in the system and find it way quicker. So it's funny. You still get comments, even though you're trying to tell people to do it right. Oh, just run the vacuum pump for half an hour minimum and you'll be fine. But essentially, you could have the evacuation done in 7 or 8 minutes. And that micron gauge will tell you that. And then you don't have to wait half an hour, right? Especially when you're doing a multi-zone. If you're doing, it's very doubtful that that person's going to have 6 vacuum pumps if they're doing a 6 multi-zone to hook it up to each one. So you're doing each one individually. And if each one only takes 7 or 8 minutes with the right setup, the right vacuum pump with fresh oil and all that kind of stuff, it might be 7 or 8 minutes, not half an hour. And then you're quicker on the job too. You don't have to be there as long.
Yeah, and there's other things, if you do the job correctly, there's other things you can be doing, whether that's cleanup or whether that's, while you're pulling that vacuum. And so it's not like you have to hover over that the entire time. Go do some other things, pick up the trash, pick up the boxes, do that kind of thing, and then work it and maybe speed that job up a little bit. But in the end, we just want to make sure we have happy customers, because to the points you made earlier, it's never the installer's fault. It's always the equipment's fault. And so I think every brand out there has gotten a knock over improper installation. And then the contractor, we love them to death, but they're one of the quickest ones to blame the equipment. So let's just make sure we do it correct. And great equipment and a great install almost every time will work like a dream. And then build your reputation, build the reputation of the brand of the equipment, and make that consumer happy. And to the point I made is now you get referrals, and that's free advertising. And there's nothing better than free advertising for your business.
Yeah. So the last thing I want to ask you about before we run, and I'm asking you about this now because I've got a dehumidifier in my basement that I run. I just plug it in and I run a hose to the drain, and I set it for 50 RH, and it just runs and helps keep the moisture level in the home at bay. The multi-zone system on the controller, does it have a dehumidification setting that you can use on it?
Yeah, so we've got what we call a dry mode. And within that dry mode, if you say, you know what, my temperature is good, but my RH seems a little high, and I'll give you the weather in Louisville, Kentucky, where I'm at our Midea Research and Development Center. It's been a rainy summer, and it has not until the last couple of days been hot. And as you know, the worst time for relative humidity is it's not really hot, but it's very wet outside. So we're not, the equipment itself isn't running a lot, and that RH begins to climb. So we've got what's called dry mode, and you can just jump in it and it will override the temperature and say, I'm just going to dry this room out. Everyone loves it because we all run into those situations where it's not the temperature, it's the RH, and let's just wring the room out. And make it work that way, and then kick it back, and you're super comfortable, because comfort is the combination of temperature and relative humidity.
Mm-hmm. What changes are made with the operation when it goes into that mode?
Well, the first thing is, and this is sound weird, but we disregard temperature. And so, I mean, we can get that coil really cold, and then we can slow that fan down. And so the air in that room, I compare it to wringing out a sponge, right? So if you got a wet sponge, you can either grab it and do that real quick, and you leave 3/4 of the moisture in the sponge, or you can just slow everything down. And when you wring it, take your time and wring it out. That's the difference. And so in dry mode, that's what we do. Get that coil nice and cold, run that air across it nice and slow, and wring it out. And in dry mode, we will go below set point if you want to, but the goal is to decrease the relative humidity. Then you kick back into your normal cooling mode, and then you've got that room nice and dry.
It's not like a dedicated dehumidification system that's got reheat. But it has a capability to slow the fan down, so we're not moving so much air through it and overcooling the space like you normally would in regular cooling mode.
Yeah, the last thing we want to do, it's not designed to be a dehumidifier. It's designed to help to dehumidify the room that you've selected it be in. And we had a terrible, terrible case it was actually in New York that my tech guys had to go visit, and they had a tiny little closet. I mean, it was a tiny closet, and they had put a high wall in there and then ran the thing in dehum mode all the time. It's not what it's meant for. So if in certain situations, to your point, and I have a dehumidifier in my basement as well, and it just runs. If that's what you need to help you dehumidify, just do that. And don't try to use the system what it was not intended for as a dehumidifier. But if you do need some flash dehum features, we can do that.
Yeah. So I want to tell a quick story, and then we'll end it off, because it was very interesting to me how this happened. And some people just don't understand air conditioning, like homeowners and people that want things installed. And so this is 3 years ago-ish, 2.5 years ago or so. A customer, they wanted no ductwork in the home. They had in-floor radiant for heating. So they wanted one head in the house, very small house. They wanted one head in the house. I said, well, you sure you don't want two, like one on the main floor, one on the second floor? They're like, no, just one. That was all their budget could allow them for. So they wanted it on the second floor. The second floor basically was like when you come up the stairs, you turn it's almost like an L shape. You turn so the head was facing like the small hallway where the bedrooms were, right? I said, if you install it here and you keep the bedroom doors open, then that air will cool the bedrooms. Like in theory, it'll remove the air out of here, and the warmest place in the house is the upstairs. So it was working fine. I get a call a year later, and it was an email. They're like, the unit you installed last year is leaking water all over the place. It should not do this, blah, 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 blah. Come back and fix it. So now I'm thinking, like, why is it leaking water all over the place? And I'm starting to get concerned now. Like, did I run the drain wrong? Did I do something wrong? I go there. They have every bedroom door closed. So it's just shooting into this tiny hallway. Like and they have the thing turned down to like 62 degrees Fahrenheit. So everything on the machine is sweating. Like it's just sweating and dripping moisture. I'm like, guys, you need to set it to 72 and open up your bedroom doors and allow that heat from the bedrooms to come out. Don't be setting it to 62 degrees Fahrenheit and closing all your bedroom doors, because now we're just trying to cool this hallway space that is 6 by 4. You know what I mean? With this one head.
Exactly.
And it had nothing to do with the install. It had to do with the fact that I told them, if you're going to use it, you need the bedroom doors open if you're going to put that head up there. And the guy fully understood and all this kind of stuff, but he had tenants move into the home, and I guess he didn't relay this information to the tenants. And anyway, I haven't heard back from it since, but I'm like, hey, dude, this is a chargeable call, man. He's like, oh, okay, fine. So I charged him for it. I said, this is not warranty. This has nothing to do with the install. It's the way you're running the machine.
That's exactly right. And, even whether it's the installation manual or the owner's manual, we'll give you some tips on some of that stuff, right? And we want to make sure on the install that we've got clearances from the ceiling, right? We've got the air throw, right? So we always, in an ideal situation, we want to throw that air along the longest part of the room, right? And so that allows us to throw it and return it, because in a ductless head, we're supplying and returning back to the same place pretty much. So let's throw it along the long part, and then we'll return it back. 7 different options on the Midea system to choose from, with combinations. We preach the, percentage of outdoor unit capacity to indoor. So we want 66% as kind of the low, and we can go up to 133% capacity indoor versus outdoor. Because understanding that in normal weather conditions, every zone's not going to be calling at 100% all the time. And so we can oversize the indoor units, 133% of the outdoor. You can probably do more than that, but just be careful, because in extreme weather conditions, you could be starving the entire system.
Yeah. And this one here, like this install with the staircase and then the hallway, it was about 8 feet of length that we were throwing that air down. And if they kept the rooms open, that air would have, like the cold air would have swept into the bottom of the room. That warm air would have came back and returned the unit. And it probably would have worked just fine if they had it set to a reasonable set point. But because the doors were closed and that little hallway, it was freezing up there. It was like literally so cold that if it was any colder, the walls would have started to sweat, because of the dew point on the wall would have started to condensate moisture. But anyhow.
Yeah. And I would just say, I've got a group that travels North America training like crazy. Whatever brand that these contractors are installing, get with your distributor and ask them to put on a very thorough training for multi-zone ductless, because again, it's not one size fits all. I mean, there are some things we need to try to follow in order to get a good install for the amount of money that consumer's spending. So put some pressure on your distributor to get some training classes together so you fully understand what's going on and how to install it, how to do all of that. And then everybody's better that way. Everyone wins with that.
Awesome. All right, David, as usual, man, it's awesome to talk to you. Multi-zone systems. I hope people are a little bit more aware of what they can do and how they're installed and how to service them and all that kind of stuff. So thank you very much.
Gary, if people have questions about Midea products, they can go to mideacomfort.us in the US, or go to mideacomfortna.ca up in Canada. Check out all the products, do some research, and then you can at least be educated. If you call a contractor out to your house in order to do a multi-zone, you'll sort of know what you're talking about too, so you can have an intelligent conversation with that installing contractor.
Yeah, and what a lot of people don't know, and you can talk to this quickly, but I mean, Medea's got a whole engineering department in Kentucky, and that's where you are, right?
Yeah. So all of the innovation comes through the Midea America Research Center here in Louisville. And so all of the innovation, all of the products, everything comes through our team here. And so, and then our technical support team is here as well. We've got one guy up in Canada, but we scour. My technical support team, just for training, we've done almost 100 training sessions across North America to date, and we're not even halfway through the year yet. So we just want to make sure, whether it's our brand or someone else's, that they understand what it does, how it works, and how to install it, so everybody's happy in the end, and we all make a little bit of money.
Yeah, perfect. Well, thank you, David, for your time, and hey, enjoy your weekend, man.
Thanks, Gary. As always, thanks for everything you do for the trades. I certainly appreciate it, and honored to come on your podcast.
Thank you very much.